What happens when a red dwarf dies? The universe is a vast and mysterious place full of phenomena we might never understand. Despite advances in science, much of our knowledge remains theoretical. But there are some things we do know about the sea of celestial objects around us. This is Unveiled, and today we're answering the extraordinary question: what happens when a red dwarf dies? Are you a fiend for facts? Are you constantly curious? Then why not subscribe to Unveiled for more clips like this one, and ring the bell for more fascinating content. Red dwarf are actually the most common type of star in the universe, making up 70% of all stars. They include the closest star to the Sun, Proxima Centauri, but as the smallest true stars, and with most of their luminosity existing on the infrared spectrum, they keep a low profile, remaining invisible to the naked eye. They're also relatively cold, burning at temperatures lower than 4,000 degrees Kelvin. In contrast, the surface of our own Sun, a yellow dwarf, burns at around 5,800 degrees. Red dwarfs burn immensely slowly and are the longest-lived stars in the entire universe, living for trillions of years. Stars shine by fusing hydrogen into helium, and in red dwarfs, convective currents replenish hydrogen in the core, while also preventing a buildup of helium there. Since the universe is only 13.8 billion years old, we've never actually seen one die, and there's the morbid but very real possibility that we never will, depending on how long our species can manage to stick around. We do have a hypothesis about what happens though. Physicists speculate that as small red dwarfs near the end of their life cycle, they'll change colors to become theoretical blue dwarfs. As the star begins to run low on fuel, its surface temperatures will increase, and it will become more and more luminous. What results won't be a big glowing orb in the sky, but a star which shifts along the color spectrum to become bluer. In contrast, however, red dwarfs with sufficient mass will instead expand and become red giants. Unlike more massive red giants, however, these won't have enough mass to become supernovas, which themselves go on to either become a neutron star or a black hole. Blue dwarfs are a very brief stop in the life cycle of red dwarfs, however. When the red dwarf finally runs out of fuel completely, it becomes a white dwarf. Unlike blue dwarfs, white dwarfs do currently exist, because other types of stars also become white dwarfs. In fact, 97% of all stars shrink and become white dwarfs rather than becoming supernovas, so there are plenty of them to observe. For stars, they're exceptionally small, about the same size as Earth, and made entirely out of helium. They're basically what's left behind after a star dies, the corpse of the star's inner core. A normal star turning into a white dwarf will shed more of its mass through a bright and vast planetary nebula until the core is all that remains. White dwarfs shouldn't be confused with brown dwarfs, which also lack fusion. Brown dwarfs are basically failed stars, objects without enough mass to have fused hydrogen into helium in the first place. They're similar to gas giants, except that they fuse deuterium, emitting very little light. Red and white dwarfs are particularly interesting for reasons of habitability. As previously mentioned, the lifespan of our Sun is sickeningly short in the grand scheme of things. Humanity can't survive without a star, and while the Sun has 5 billion years left until it dies, there's only 1 billion years left until it heats up too much for the Earth to sustain life. To have any kind of future after this point, we'd need to find a new home. That's where dwarf stars come into play. The odds of finding a habitable planet orbiting a red dwarf are pretty good. There are an estimated 100 billion stars in the Milky Way, and between 70 and 80% of these are red dwarfs. Within these 80 billion stars, there are an estimated 60 billion Earth-like planets which might be capable of supporting life, and we only need one. Once settled in, we wouldn't have to worry about finding another star to orbit for an awfully long time, thanks to red dwarf stars' exceptional lifespans. However, there are some problems with this red dwarf utopia. Because they're much dimmer and colder than the Sun, Their Goldilocks zone is much closer. We'd need to be the equivalent distance from the red dwarf as Mercury is to the Sun now, which is very close indeed. So close in fact that the red dwarf's immense gravity might force any planet to become tidally locked, meaning it wouldn't rotate. One side would permanently face the Sun, while the other would be in constant darkness. Not an ideal place to live. While in the right conditions, clouds and seawater might still warm the night side of the planet, we might be better off colonizing moons that are tidally locked to their planets instead of the red dwarf. When it comes to colonizing a white dwarf system, the same ideas apply. White dwarfs would actually be more stable than red dwarfs though, and still take an incredibly long time to cool, especially since their temperatures begin roughly 40 times hotter than the temperature of the Sun, over 20,000 degrees Kelvin. Since white dwarfs are already technically dead and just cooling down, however, there will come a point where they cool and fade enough to become simple black dwarfs. Black dwarfs are celestial objects which don't emit light at all. If you saw one, it would look a bit like a black hole without all the distortion or immense gravitational pull. In fact, alongside black holes, black dwarfs will be the last things that exist in the universe when heat death begins. They eventually stop giving off any heat or light, dwindling to the same temperature as the cosmos itself, which is only slightly higher than absolute zero. Again, mind you, black dwarfs, just like blue dwarfs, are unobserved and hypothetical. Red dwarf stars may be common, but they're still remarkably mysterious, even though they could one day become our best hope for a new and permanent home. What do you think? Is there anything we missed? Let us know in the comments, check out these other clips from Unveiled, and make sure you subscribe and ring the bell for our latest content.